Hey everyone, how are we doing? Hey, what's up, Zoe? Zoe, good to see you here. Is it Zoe or Zoe? Hey, what's up, Sarah? Which questions do we have? We just finished class a little while ago, went and had some food left over. We made basically like Thai food last night. Kind of, I mean, like as best as I can make it. What's up, Logan? Logan, I'm so sorry I reset. You might be on a different account, maybe. I reset the points this semester. Points were reset. Kirsten, so good to see you. In class, remind me to make you a mod. I will make these people mods in class. What questions are there? Hey, Sarah, good to see you here. Be like, Brian, I am working on this. Brian, I need to understand this. So many points. People already, I'm going to have to make new tiers. Should we make a new tier? What should the highest possible tier be? I don't want to tell you what these secret tiers are yet because no one's gotten to the highest tiers. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, and there needs to be a 10th tier. What would be the 10th tier called? Brian tier. We could do that. Hey, what's up, Isabel? It's good to see you here. Oh no, Logan, I know what it is. Logan, we switched. So Logan, what happened is I used to use no, Logan, I know why your points are not there. Let me add points to you, Logan. I'll add you some points. I know what exactly it is. So Brian tier. I might change this. Who knows? Requirement. There we go. Okay. There is now the there we go. There's now a higher tier. There's the Brian tier. I might change it eventually, but right now it's Brian tier. So what happened, Logan? Let me add Logan's points here real quick so Logan gets some points. Check your points in just a moment, Logan. We used to, as you know, stream these. So Logan can tell you that we would just do these. Oh, you're not showing up in the thing yet. Logan will tell you how we just used to do it. I think you'll show up here in a second because you just joined the chat and you haven't gotten points yet, so Mubot will start tracking you. So Logan, you probably don't remember this. Oh yeah, let's do that, Miranda. We'll talk about that next year. You got it. Did we have quotes before, Logan? Like we did not have quotes when you took this. So now we have tons of quotes. But I had to make a bot for the channel, and so it restarted the points. So this is a different bot we use now, and then I reset it every semester, and your hours are not here because we're using Streamlabs to do it before, but now I use a bot to do it. So I had to figure out how to make a bot for the channel, so I've done a bunch of different things. And so there you go. I like it. We got that quote from last class also. Love it. So we got a bunch of, what's up, Miles? So good to see Miles. And Logan, when I see you in the system right here, I'll add it. Let me go away from this. I'll probably add it in a little bit here, but I don't think you're in the system yet. Mubot has not added you. And everyone knows we already have Mubot here. Let's go say hey to Mubot, and then let's hop over. Mubot, how are you doing, Mubot? What's going on? There's craziness going on right here.
Evil Mubot can take away your points. Let's do this right now. Points, remove, viewers, enter this command in Mubot. Good. Mubot has now taken away a point from everybody. I hit the wrong button.
Oh no, the boss is still here. Let's make the boss go away. What? Mubot, you're not supposed to do that to people. We're gonna get serious here in a second, but Mubot. We don't like evil Mubot. Let's give people 11 points to fix that. All right, we fixed it. Let's get serious here, talking about we got some center and spread here. Let's do this. Let's hop to the main screen. Okay, center and spread. I know, my precious points. Got some chill music going on. Okay, it's time to get serious. Okay, let's get serious here. Okay, so when we talk about center and spread, how do we know which measure of center and spread to use? How would we know which measure of center and spread to use? We should know this instantaneously. Like, for those who've been to multiple office hours, you'd be like, we know center and spread based on this. I've got the hints on the screen. Oh no, Isabel, OIT. If it's crashing, let OIT know. Someone emailed me. I've had maybe 2 or 3 emails about it crashing. That's going to be a computer OIT issue. Call OIT immediately and see my computer's crashing when I try to run this program. What's up, Mun? So good to see you. Hannah's right, the shape. So the first thing we need to talk about is the shape right here, and we have a lot of color coding. There, OIT numbers like 9749900 or something like that. Double check it. OIT UTK and look at the bottom of the site. Does everyone notice the color coding right here? We've got red and blue. So when data is skewed either direction, there's just a mark off follow instruction, but nothing show up. Yep, I'll send that here in 2 seconds. Kira, you got it. Is it Kara or Kira? I'll say it the right way. Does everyone notice right here that the center is either going to be mean or median? The spread is going to be standard deviation or IQR. I'm going to pull up the link here while I talk this through. And with that right there, you need to know the shape of it. You need to know the shape of it. The shape of it is going to tell you which is the proper measure of center and spread. And so when Macs are in night modes, this is to Kira's question right there. When Macs are in night mode, for some reason, it doesn't show the numbers. So let me see, just make sure I'm pronouncing your name correctly. Like Shakira? Okay, Kira. So Kira, this is the issue you're having. Let me mute myself in the background. So the issue you're having right here is that the numbers are not showing up like they should be right here. But go to the Mac button, the little Apple right there, go to the Apple button and go to System Preferences, Apple, then System Preferences. Go to General, and under General, over there on the left, Brian, there we go. Under General, you'll see Light or Dark Mode, and I'll put this video as a link in the chat so people can see. If you change this to Light Mode, the numbers will show up when you put them in. I don't know why. A lot of people running this issue, it's just Macs in night mode have this issue. So once again, to fix this issue right here, you will go to the little Apple icon in the top corner, click it, System Preferences. Then you will go to the General button over here. I couldn't find it when I was making this video. I was like, where is the link? There it is, General button. And then you'll go to Light Mode. Go to Light Mode, and that should fix it. When you go to Dark Mode, they disappear, and when they're in Light Mode, they are there. That seems to be the biggest issue. And I put the visualization playlist in the chat right here, so check that out. So do you want our bar graph to have separations in it? Oh, because this one does. When you make the bar graph this way this semester, it won't have separation. This semester, we're doing it a tiny bit different. I'll show you the two versions right here. So this is categorical data right here. And with the categorical data, if you do it this way, which you're told to this semester, which is a little different than last semester, you will see the following. So you will have no separation. We should accept either way because it is in the video. Maybe I'll tell Terry, I'll be like, when you're telling the graders, tell them if they made it via Graph Builder, it should be all right either way. But this is the way we want it made this semester to like change it up a little bit. But under Graph Builder, it doesn't have separation. Under Graph Builder, when you go to the bar chart here and you put the numbers label value, it will not have separation. So just a little bit different, just a way to visually display it differently right there. No, really good question. Thank you, everyone, Catherine, everyone. Going back and talking about the shape center spread, the things we need to know. So also, why didn't we make the bar chart the same way we made the pie? Just to kind of mix it up, show you different options. You can make it. There's tons of ways to make different things inside of Jump. And I don't know if you can I get back to that data pretty easily? I need to close down this computer. There we go. I don't know if you can easily change this over to a pie chart. I don't know how to make it a pie chart from this screen. So I don't know how to make a pie chart from the analyzed distribution. It makes a bar chart by default. But when it comes to the center and the spread, if your data is unimodal and symmetric, you'll use the mean and the standard deviation combination. And here's a really quick way, and Keegan, good question. Where do we go download Jump? Let me send you that link in the chat. A really easy way, especially when you get to the test. Like if you ever forget which go together, I'm gonna send the playlist in the chat right here. If you forget which of these go together, like do the mean and the standard deviation go together? Or do the median and the standard deviation go together? And Keegan, I'm dropping this in the chat right here. It has both videos. There's the Mac video and the PC video in that playlist. Like you'll see the playlist on the right. But if you forget which of these go together, I want you to look at the output when you create output. When you create output in Jump, take a look at it. In the output, what do you notice together over here on the right? What two numbers go together? You're welcome, Keegan. I try to do as many questions as I can. So what does each color stand for again? I'm just color coding what concepts go together. Does that make sense, Miranda? The mean and the standard deviation. The mean and the standard deviation are labeled blue in this because when you're using the mean, you're also going to use the standard deviation. They're concepts that go together. You notice how mean and standard deviation are right next to each other? And then if you notice, when do we use the mean? Like, can you explain to me, when do we use the mean? Look at everything that's blue and kind of tell me conceptually, when do we use the mean and standard deviation? So look at all the blue things that are color-coded together to be like, oh, we use the mean when data is generally more this, does not have this, and does not have this in the data. That's generally when we use the mean. It's a better measure of center, and it goes with the standard deviation, the measure of spread. So this data we would not use the mean and standard deviation for. And the color codings to help identify the concepts. Exactly. Hannah, great job right there. Exactly. So if you notice the color-coded concepts right here, showing you that when the data is, and this data has a huge gap, has a huge right skew, so the proper measure would be the median and the IQR. Now, can anyone mathematically figure out the IQR? Like, if you know the IQR, yep, Mon, great answer right there. The gap is just this right here. So this is the big gap in the data. Noticeable, like, noticeable areas where data is not contained. That's what a gap is. Just a big, like, just a hole in the data. Yes, nice job, Hannah. So and everyone, great practice right now. The more you practice this, the more you hear this. And if you can look at this data, and like Hannah just did 2 right there, if you know what the IQR is immediately, you're good. You instantaneously know the IQR. You can cheat. I mean, it's not like cheating, but you can go right here and go to customize summary statistics and select the interquartile range. And it's just going to mathematically find this distance for you, which is the 75th minus the 25th percentile. So big important stuff right there. Is this keep asking questions? These are your guys' office hours. So I want you to ask the questions and be like, hey, Brian, can you explain this? Can you go over this? We can do visualization 3. We did visualization 3 earlier this week, but you can say whatever you want. We can review concepts. We could do the next chapter. It's your guys' office hours. So how do you find the IQR? Really good question. Let's review that briefly here. To find the IQR, we need a new word sheet. I got to close down this computer. To find the IQR, we got to know what the IQR is. Let's break down what IQR stands for. I stands for inter. The inter what? The interquartiles. The IQR is the interquartiles. So we have here the interquartiles. So when you talk about the interquartiles, between what and what numbers here are the interquartiles? Between what and what numbers here? Great job, people are doing it mathematically. And this, if we can like draw this and remember this, then we have it down. Exactly. And it's the range of these numbers. So the IQR is the interquartile range. Would everyone agree with me that if you go all the way right here, I'll put that on the bottom so it doesn't look like it's the IQR. If I go from the lowest number to the highest number, what is that concept? Like if we were to call this right here the minimum number, because that's before we have any data, the lowest point in the data, or the maximum, then this would be the what right here. This blue line is showing us that's the range of the data set. That is the range of the data set. So we have here, exactly, that's the range of the data. So the IQR is going to be this distance right here, not the full range of the data, but the range of the middle 50%. There's the interquarters, and their range. So here, let's color code this. This might really help some people get it. We got inter right here. So the inter is showing us like this inter. And when we say quarters, we're talking about like the idea of them being quarters. And when we're talking about range, we're just talking about a distance right here, like the distance they are apart. So it's the interquartile range. So it's just taking like a smaller amount of the data, and it doesn't include outliers. Like outliers would not be included. So what are we going to call, let's do the easiest thing first. What should we call the middle number in the data set? Like, what could we call that number at the very, very center of the data, which we're not going to use right now, but it's a good measure of center. The number at the very, very center of the data is the median. And this will come into big use for box plots because that's the center of the box plot. Nice job, Macy, right there, and Hannah. So now it's like, wait a minute, what are we going to call where 1 and 3 were at? Well, these are the ones people need to learn a lot of times, and it's easy to remember. It's just the first quarter and the third quarter. So think about how we've done this right here. We've shown what the IQR is, and people are putting in the chat what the formula is. It's Q3 minus Q1. So when you see a data set, do we still have that data set open? Yes, we do. When you see this data set right here, how would you find the IQR? What would you mathematically do to find the IQR here? So we have to look over here where the quartiles are at, or the quantiles, and we have to say, okay, we need to find the 75th percentile minus the 25th percentile. And what would we mathematically do to get this number of 2 right there? Exactly, Hannah. And so, Hannah, did you know how to find the IQR before this class? Like, could you have been like, that's 2 instantaneously? Nice job, Keegan. Keegan pointing the answer 2. Let's put some points to the viewers right here. I really love, like, it's sometimes, especially after tests, no one shows up to office hours. And then I'm like, okay, I'm just hanging out here. No questions, anybody? Throw some points to viewers. Not before stat 201, but once office. Exactly. And then once you know it, it's like, oh, the IQR is just the range of the middle 50%. It's just the distance those two numbers are apart. So the thing is a lot of times you don't even think about the formula now, because if you understand it conceptually, you can come up with a formula on your own. So if you look, I don't think Hannah spent a bunch of time sitting down being like, it's Q3 minus Q1, it's Q3 minus Q1. But if you memorize, it starts at the 25th, goes to the 75th. Well, that's just 3 quarters and 1 quarter. You just kind of build upon existing knowledge of what quarters are, and it's the distance the middle 50% is apart. It's the distance of the middle 50%, or the range of the middle 50%, I should say. And it's a measure of spread. It tells us how spread out the data is. Is it always Q3? Great question, Miranda. It is always Q3 minus Q1. It's always Q3 minus Q1 because the IQR makes up 50% of the data. So it's the middle 50%, the range of the middle 50%. Great questions. What additional questions are there? What additional questions are there? Let's put on some Celeste music while we ask questions here. It's not Celeste. So Q4 is technically the max. Great question right there, Miranda. Q4 is the max. I've rarely heard it called that, but all of these could be called Qs. Like, technically, everything can be described here as Q. Like, that just sounds weird. We're not conspiracy theories here. We're not gonna get this video demonetized, but all this could be done right here. How do you open up Jump? If you have issues, oh, never mind. Please email me if you have issues downloading it. But all those can be described that way. The visualization number 2 video and officers helped me so much with what the IQR is. Nice. I try to put in a lot of notes for the videos. I try to ask like kind of teach things in the videos too. So the videos are meant more than just like, here's how to do it. It's meant to be more like, here's some tips and tricks. What should we do if we can't tell if the distribution is skewed or symmetric? So let's bring up some graphics here. So generally speaking, you're going to see in stat 201, we generally try to show you things that look like this or like this. And so the top one is more symmetric and the bottom one is more skewed. But you could see something. So does your graphic look like A or B? And it could be left skewed also. Like, we could do a left skewed distribution. So it could be this also. There's tons of ways distributions could look. But if your graphic looks more like A, it's going to be symmetric. It looks more like B. Yep. And you could have some sort of hybrid of the two. Like, there's weird distributions, like things that just like, what? But you could have something that looks something like this right here. And you could say there's a slight right skew. But all the graphics I've drawn in red right here are kind of your, like, this is your quintessential symmetric, like really good, like this is very symmetric. This is very, very right skew. This is very left skew. And this right here is a mostly symmetric, but a little bit of a right skew distribution. So that distribution has a little bit of right skew. There is a way to tell, though. If you're like, Brian, I'm still scared, I'm going to get this wrong. There's a cheat. There's always a cheat. So the way to find out if something is skewed and in what direction is, and you guys are doing tickets sold, right? I'll do raw sales. I know you're not doing that one. So I'm trying to do a variable you're not doing. Woo, look at that distribution. That's a right skewed distribution. So that is ridiculous. So the way to tell if it's right skew is the following. Usually the mean will be what to the median. So this median right here is 176,000 and the mean is 13.5 million. So the mean will be what to the median if it's right skewed. The mean will be what to the median if it's right skewed. And I'm going to show a smaller data set because I think that'll be easier. So, and then we'll do that. Cool. If it is right skewed, because it's going to be easier to look at, if it is right skewed, then the mean will be what to the median? If it is right skewed, it'll be greater. Exactly. The mean follows the skew. If you look at this, the median is 2. So the middle number here is 2. I believe it's 8. Yeah, it's 8. Or the 8th number. It's not 8. The 2 is the median. What is the IQR on this? For someone who didn't know, nice job, Macy, right there. I understand. Are you solving anything? Question, you had a few formulas on there. For example, when I'm describing shape. Yep. That's generally what you're doing. Hi, right there. You're going to talk about it, and you're just going to describe it, and then you're going to tell someone what the median is, but make sure to give the context. Yeah, nice job right there, Mon. Great advice. Once you download it, it should automatically work. It should open the files and everything. Who knows what the IQR is for this immediately? And I'll show you a trick to get to know what skew is exactly really quickly. Generally speaking, things that are right skewed, the mean will follow the direction of the skew. Does that make sense, Miranda? I am drinking, it is a ginger drink. So this is one of my favorite drinks right now. I'm trying to think what company makes it, but it's a ginger drink, and I'm hoping it helps. Last semester I had stomach issues, like maybe stress, who knows? I don't know what. I told students eventually, because too many of them I feared got worried about me. Don't worry about me, I'm fine. But it's a ginger drink. So I think it's helping me. I don't know. Last semester was craziness. But I'm all right. Have you ever tried Miranda from Coca-Cola? I'll have to try that. Is it like a ginger drink? If so, I'm going to like order it later today. But I've heard ginger helps with a lot of issues. So I'm just like, man, I sound old. Got to drink my healthy drink to stay healthy. Drink kombucha or stuff like that. So here's a trick. Roger, great stuff right there. Roger, watch this trick. You ready? We're going to go here, and we're going to go to Customize Summary Statistics and go to Skewness. Now, something I haven't told you is that right skew is positive skew. So as everyone see here, this has a positive skew to it. Does that make sense? So this is the skewness of the distribution. And so for Roderick, who I know is in 320, watch this. This distribution you see down here would have a skewness value of what? Who has any idea? I just played music instead of making myself disappear. Who knows what the skewness of this distribution on the bottom would be? So look at it real quick and think of what the skewness value would be. Who has a guess what the skewness of that distribution would be as I type a little bit of code? Who knows what the skewness of that distribution would be? Any ideas? Well, doesn't it look symmetric? Since it looks symmetric, the skewness of that distribution should be what? It doesn't have positive or negative skew. It's not right to the high, left to the low. The skewness of it is going to be very close to 0. Nice job, Hannah, right there. And now let's do this. This is random exponential numbers. So these are all random exponential numbers. So we're going to make a distribution here. And 201, you should know this. What way is that data skewed? This data is skewed to the what side? This data is skewed to the what direction? This data is skewed in the what direction? To the right. And that means it has positive skew. But what if we were to change this? I think that'll work. And now this will have what skew? Because this is pulled to the low side. Since it's not just because it's negative, just before anyone thinks it's negative skew because it's... Now it will... now with the numbers... Oh, did I not mess it up? What did I do? Oh. Maybe I need to put the +10 inside of here. Maybe? Oh, because it's a vector? There we go. So now it's left skew and it'll be negative. So you don't have to know the negative part of it, but there is a way to tell. Like if you're like, I don't know which way it's skewed, there's a mathematical way to tell. So you don't have to actually guess. We should know that this right here is a symmetric distribution. You don't need to know that it is going to have a skewness close to 0. You should know visually that this is a left skew distribution. You don't have to know negative, but it's pulled to the left. And if knowing it has negative skew helps. So if you're ever really concerned, you could just check the value of skewness. Does that make sense to everybody? Like if you're like, wait, is it positive, negative skew, but positives to the right because the high numbers are to the right and negatives to the left. Remember, whatever way the tail goes, if you draw your little monster dude here. So keep asking questions, but that's also why I love coding, because I can like make these distributions really easy with code right here. I can just code random numbers. So I'm confused on the center and the spread part. How do we provide only the appropriate measures? Great question right there. So when we talk about the appropriate measures, what must we first look at? So I'm going to bring up our really good help document we have right here. When we look at only the appropriate measures, and if you don't have a screenshot of this, take a screenshot. So what must we first decide? And this is big for 320 also. Whenever you're getting off to mess up on numbers. What must we first decide on to know the proper measure of center and spread? What must we first know to know the proper measure of center and spread? You must first decide this. To know the proper measure of the center you will use. Modality is not the most important. Modality is part of this. The shape, you're right, Mun. You must first decide the shape over here. Is it looking like this? Or does it look more like this? And it could look left skew. What does one, expand more on that, Miranda? Oh, 1 standard deviation. My handwriting is horrible. That means Brian has really bad handwriting. 1 standard deviation. No, don't worry. My handwriting is absolutely horrible. I had a job where they walked up to me and they're like, Brian, so your reports. And I was like, yeah. And they're like, we need you to use better handwriting. So yeah, my handwriting is bad. It's pretty bad. So don't worry. Feel free. If you can't read something or it doesn't make sense, just ask. I love that quote, Campbell. So does everyone notice everything in green kind of tells you how spread out the data is? The yellow is the center. So to know bad handwriting is a sign of intelligence, you know what I equate it to? Here's the truth about it, and feel free to ask more questions. But I started, I got caps lock on. I started using computers when I was about 5 years old. My dad had gone out and bought a TI something computer. These were really big in the 80s. Because of this, I am able to type pretty well. Sadly, though, autocorrect, come on. I cannot write at all with my hands. Nothing right otherwise. Brian sus. So I'm able to type pretty fast, but as far as handwriting goes, pretty bad. Also, I'll just type it on a computer. It's really like story. Can you explain more, Brian? I'm still confused. Which part he ate? Let's go back to that real quick. Boop. Which part are you confused about? I've been using computers sadly for like 34 years, so it's kind of bad. Divine standard deviation. Oh, really great question. This came up during office hours or came up during class at the end. Okay, so I want to show something right here. This will help with standard deviation. Okay, so what is a standard deviation? So standard deviation is best used when data looks what? Standard deviation is best used when data looks what? Like, when do we use standard deviation? This is something we should know like that. When data looks what? We should use standard deviation. And this is a hint on the screen right now. Unimodal, symmetric, does not have outliers, looks like this data right here behind me. That's why I'm going away so you can see it. So does everyone notice here the number line on the bottom? I want you to take a look at this number line. Look at where 799 would be. What is the standard deviation right now? The standard deviation is 1. Tell me, what does the mean control in this distribution where the what is for the data? What does the mean control for this distribution? Look at how when I change the mean, what does it change about the distribution? And I might do something, Roderick, to make my life easier. You know what I might do? No. It's good enough. I just changed 2 things. What is the mean control for the distribution? What is the mean of the distribution controlling? It's 10,000 technically. It's not. Oh, I changed it in that moment. What is the mean of the distribution controlling? Oh, I'm controlling how many data points there are. I'm losing my mind, everybody. What is the mean of the distribution controlling? Look at this number right here, and then look at this. What does the mean, because this is the mean right here. What is the mean of the distribution controlling? The center. The mean is the center. Does that make sense? The mean is the center. So if I change this to 5 right here, look at where the center of that goes. Does that make sense? The mean is the center. It's the average of all the numbers, and it's what is distributed around, Roderick. When we get to standard deviation, That's what we're talking about, how far things are typically from the mean. What if I change this to 5 right now? The distribution will get more what? Like, just try to use your own words as you see as we go from a standard deviation of 1 to a standard deviation of 5. The distribution gets more what along the number line? What if I went to a standard deviation of 0.1? What is the standard deviation controlling for the data when I now make it 0.1? It's still centered at 5, but now when you look at it, it has a, what's the difference here? So think about what we talk about with shape, center, and then what does the standard deviation control? The spread of the data. Does that make sense, Mon? Does this help seeing it visually? That here the standard deviation is 5. It's still centered at 5, but it's more spread out. Here the standard deviation is 1. The center's at 5. And if you go down about half of the width of it, and you'll see the distances that it is away. It's typically about 1 away. But you can see with the different standard deviations, it controls how spread out the numbers are away from the mean. So the standard deviation is the typical distance or about an average distance things are away from the mean. Does this make sense to people hopefully seeing this? Like, I hope like you can visually understand, like, what do you think test scores look like? Test scores in Stat 201 or BS 320 would probably have a mean of what? Like, let's say we generate the test scores for all 1,400 Stat 201 students. The mean of their scores is probably what? That's how many scores I'm generating here. The mean of their scores is probably what? What do you think a mean score for Stat 201 students would be? 75. And remember about how far out this goes. About 2 standard deviations is here and about 3 standard deviations is here. So what do you think the standard deviation would be? What do you think a good standard deviation would be? Because remember, if you go out 1, 2, and 3, so be careful, because if you go out 3 standard deviations, that's pretty much the whole curve. Exactly, Miranda. That's correct. So 2 is going to make it really tight. Just so you can see, 2 is going to make it really tight that pretty much all students would be between a 69 and an 81. So probably right here, you'll see, oh, I didn't regenerate the data. So you see, and if I regenerate, we'll probably get those exact numbers I said. Oh, we're so close. I guess it just doesn't want to, because I went out 3 standard deviations. And these are all normal curves right here, or they're just histograms. So everything you're seeing right here is a histogram. Jump can also do it. Is this making sense, Miranda? So who has and Roger, great answers right there. Let's throw some points to the chat. All this interaction with one another. Points, add, plus, viewers. I'm giving out too many points these days, but whatever. So, as in your comments, I'm just confused, Miranda. Elaborate a little bit. And does anyone have another standard deviation we should put in here? Because I think 2 is too small, because now students are basically making between a 68 and an 82. Like how I said, things from the mean. So standard deviation is basically the distance. Yeah, Miranda, that's right. Like how far the observations, like how far are students' grades usually from the mean? So like what is a typical distance a student's grade is from a 75? What do you think a typical distance a student's grade is from a 75? Like in this context, it's exactly Mun, that's exactly it. 5 is probably going to be better. I might even go a little bit higher. Let's take a look at 5 right here and see what if we assume the standard deviation is 5. Now, if you look at the distribution, students are making between like a 60 and a 90. So let's go right here. And usually you want to go about 3 standard deviations. So let's make this 10. It's a nice, neat number. And we're going 3 standard deviations up. Where should be the top of this distribution? We're going to make this 70 to make our life really easy. What do you think will be the highest number on this number line? Because usually you go up about 3 standard deviations and down about 3 standard deviations. You got it, Miranda. So what do you think will be the highest number on this number line now that it has a mean of 70? Broderick, you're getting it. If I generate this, look at that. You got it right there. That's how you, if you understand what standard deviations are, most of the data is within 3 standard deviations. If you took Stats 1, you'll know the 68, 95, 99.7 rule, and 99.7% of data should be within plus or minus 3 standard deviations. So I pretty much knew that this curve would go from about 40 to 100. So that's what I was doing before when I was subtracting off 3 standard deviations using 2. I went down 3 standard deviations. Is this making sense to everybody? Here we'll just do another review one. Let's say we see how many push-ups people can do. It probably would not be normally distributed. But where do people think the bottom of this distribution will be? This distribution will generally go from blank to blank number. So standard deviations. So you're just going to take right here the 5. Here, I'll draw it out in a second. Good question, Miranda. Here, I'll draw it out for you. I'm going to do that next. So you're going to see an in-depth example here when I go out 3 standard deviations. Where would be the bottom and the top of this? Because this is chapter 5, and this is one of the hardest chapters. Hearing this now is going to help out a lot for Stat 201. What's going to be the lowest number on this? Hannah, you got it. And it's not always going to, because it generates differently. These numbers are random, but it's going to about be that. So let me reappear and let's show what I'm talking about. What do I mean by 3 standard deviations? So we can say things are normally distributed with a mean and a standard deviation. This is important notation. So I'm going to choose the value of the mean. So this stands for the mean, mu, and sigma stands for the standard deviation. So we're going to go a mean of 20 and a standard deviation of 5. So when we draw out the curve right here, and we do our normal curve, at the very center of this curve, what are we going to put? If 20 is the mean, I'm just kind of giving a huge hint right here. If 20 is the mean, what will be at the center of this curve? If 20 is the mean, what will be at the very center of the curve? Because 20 is the mean. 20. Yep. Don't worry. I'm not trying to trick anyone. And then we're going to go up 1, 2, 3 standard deviations and down 1, 2, 3 standard deviations. And all we do is we just add each time. We just go here and go 25, 30, 35. And then we just subtract and we go down 15, 10, 5. And then we can also put z-scores, which I can go into if people want. But that's how many standard deviations we are above or below. Like the z-score is just a measure of how many standard deviations you are above or below the score. This is chapter 5. If you're like, okay, I'm kind of getting it, don't worry, we're way ahead on this. But does everyone understand right here that all I've done is draw out a normal curve, and then we just go up 3 standard deviations and we go down 3. You just get data, put it all together and get it. Yeah, and you see. Yeah, exactly. Exactly, Roderick. You just want to see, like, you put your data and see how it works. You see if it's normally distributed. But does this make sense when we say to everyone right here, does everyone understand this concept of drawing out the normal curve and going up and down 3 standard deviations? How's that look right here? And excellent work, everybody. Like, excellent work. Like, lots of help. We got 320 here. We got 201 here. Because this is important for 320. Like, knowing if data is normally distributed or not. Distributed. Oh, so the 5, I made it up. Really good question right there, Miranda. 5 was just made up. Like, let's say we look at, I'm trying to think of something like not like scores on a test. What should we collect data on? No, really good question. Be like, where did you come up with 5 from? I just said like 20 is the mean and 5 is the standard deviation. So I made it up on the spot. How about we look up, like, oh man, what if we look up calories in a Moe's dish? How many calories would there generally be in a Moe's dish? Like because different people work at Moe's, right? So there's variation in it. There's variation in the dishes. So we given a format. Yep, exactly. So what is the first thing is the mean, and what's the second thing is the standard deviation. So the first thing, and thank you so much, everybody, helping everyone out. So the first object is the mean, and the second object is the standard deviation. So what do you think, if you went to Moe's and order the nachos, what is the mean amount of calories in Moe's nachos? What would be the mean amount of calories in Moe's nachos? With some good cheese sauce. You walk in, they say, welcome to Moe's. You say, good. 1,000. I like 1,000. That's a nice, neat number to work with. I think that's excellent. So let's go with 1,000. Do you think the standard deviation should be 2? Do you think it should be 20? Do you think it should be 200? Do you think it should be 2,000? What would be a good standard deviation? We can make it a nice number, but if you say the standard deviation should be 1, I'd be like, 250 might be a little bit large. Because it'd be a pretty big outlier. So standard deviation is how far out the data is spread. If we choose a standard, because I can draw this out by hand, but then quickly, 50, it's probably going to be like, I'm so between different numbers, because if you think about this, because are we saying, here's the problem. Let me just explain this like theoretically for a moment. Are we saying that these are the different nachos that people order because maybe someone just gets nachos with light cheese and that could have like 300 calories? Like if it's just some chips with some cheese, that might have 300. The jalapeno just will send you over the edge. And then if we're letting people get like crazy stuff, like they might get like double cheese and double sour cream, and then it might have closer to 2,000 calories. So we have to think about the range of the data, right? Let me ask this. Here's a good way of asking it. What do you think, without going to the most extremes, what do you think is the lowest and highest value of calories that people would have in their nachos? Like, not going to the extreme, not saying someone just literally dumps the whole container of cheese on it. Like, what do you think, without super extreme values, what do you think is the end points of it? 750 to 1250. Okay. So if that's it, there's a really nice and neat number we can use. Just go to 700, 1300. So using 700 and 1300, what would be a good standard deviation for this? Using 700 and 1300, what would be a good standard deviation for this? So because we could do 750, 1250, but it's easier if we do 700, 1300 using, exactly, Roderick, exactly. And I think that's good right there. So with our understanding, we'd put 1000 here at the center, and then we'd go up 1 standard deviation, up 2 standard deviations, up 3, and then we'd go down. Does this make sense to people right here? This is how many calories are in your Moe's nachos when they make it. And maybe it's like a thing like a thing they make with like cheese and like a standardized thing. So there's going to be variation. Sometimes it's going to have a little more, sometimes it's going to have a little less, but we just went up and down 3 standard deviations. And choosing the endpoints kind of helped us be like, well, somewhere between 700 to 1300 calories, generally speaking. And it'd be rare that it had this much. It's more likely to have 1000 because that's the center. So is this making more sense to people as we talk about like Moe's? Welcome to Moe's. Should give Moe's shout outs. So you know what the fun thing we could do is? We could simulate it. We could like simulate going to Moe's. We could call it like Moe's trip. So 320. Can I get a one-on-one office hours when you're available? I meet with Zoom sometimes to figure things out. What were you wondering about? I always like to like record things. So on the number line, you can add and subtract standard deviations from the middle. Is that how you determine the numbers to be on line? Exactly. So whenever someone gives you, notice this right here. I want you to tell me what number, and this is kind of, I want you to tell me what number do you think this will go up to? That stands for fun. I was trying to type function right there. Oh yeah, here, I'll go back to that in 2 seconds, Miranda. Yeah, we'll hop right back to that. What do you think? Let me vanish. When I run this and make this right here, it'll have a center of 50, but what number do you think this will go up to right here? It'll have a center of 50, and what number do you think it will go up to? So it'll have a center of 50, and then what number do you think it will go up to on the number line? It'll have a center of 50, and then what number do you think it will go up to? That, close. So go up 1 standard deviation, so 57, there you go, Mon, you got it. So 50, 70, 90, and there we go. It's random, so it's not always going to show those numbers. Actually, you know what? There might be a way to make it do that. But it's generally going to be about that. So this is random what it makes, but generally you're going to see about that on the number line. So probably if I use 10, it's going to do it. It'll go up to 80. Show 80. Wait, oh, I didn't change this. That's what's generating it. There we go. So it is random a little bit what it makes. Just so there can be outliers. Yeah, no worries. So Miranda, do you have questions too on the other part? Let me go back to that sheet right here you're wondering about, Miranda. Were you still wondering about this? We just go up 1, 2, 3 standard deviations. We go down 1, 2, 3 standard deviations. And we use standard deviations when the data is normally distributed. Oh yeah, the symbols. Let me write that down. Mu is the mean. It's technically population mean. Mu is the mean. Exactly. You can go more than 3, but we only plot out at 3 standard deviations. And this is the standard deviation. They're both population terms, and the order they go in is right here. This is one of the harder concepts, so I'm really glad we're doing this today. So if you're getting a head start on this, then you really are understanding one of the more difficult concepts in the class. The mean is right here, and then we just go plus 1 standard deviations, plus 2 standard deviations, plus 3 standard deviations. And that's a z-score right there, which is just, so we just go down and up standard deviations right here. Is that starting? 68, 95, 99.7. And this is chapter 5. We're going to do a whole big chapter on this. If you're totally confused and you're in 201, do not worry. The big N right there stands for normally distributed. So that big N right there stands for normally distributed. So let me ask you this. 68% of Moe's nachos are expected to have calories that are between what and what? Like 68% of the time when you go to Moe's and you order your nachos, it would be expected that the calories in your Moe's would be this much. 68% of the time, it is expected when you go to Moe's, the calories in your nachos, it just tells us how the data is distributed. So it's not like a mathematical equation where we solve it. It's to describe how this looks. Does that make sense? Like it describes that this data looks normal. So when you see this right here, this tells us that the data looks normal. And this is going to then tell us where the mean of the data is at. And then the last part right here is going to tell us the distance things are away, like these distances right here. So I'm hoping the color coding like really helps. So that's going to tell us the standard deviations up and down. Does that make sense, Miranda? So keep asking the questions because I've been doing these things for 10 years. So when I look at it, it makes sense. But I hopefully like the color coding helps. Like the big N stands for the curve is normal looking, unimodal symmetric. And then the first number is the mean of the distribution, which is the center. And then the next number tells us the typical distance things are away. Yeah, I think color coding helps a lot. Just if you don't get it, just ask. Just keep you like, I still don't get it. And I'll be like, let me try. We'll get this figured out. But 68% of Moe's nachos would be expected to have calories between blank and blank. Exactly. And this will be start of a week from now, like more than a week, like nine or so days from now. We might get to it by the end of next week. Chapter 3 and 4 are short. I like to start chapter 5 early because a lot of people haven't seen this. Like, we're doing bar charts, pie charts, Pareto plots. Everyone's like, that's so easy. And I mean, it is. And that's why we do it a little quickly. We slow down when we get to this chapter. This is a tough chapter. 68% of Moe's nachos are expected to have calories between blank and blank. I'll give some hints. 68% of Moe's nachos are expected to have calories between blank and blank. Nice job, Macy. Excellent work, Macy. 900 and there you go right there. That's got it. That's how we do it. Is it starting to make sense right here? Do you guys want to do a harder version of the question where I don't tell you the answer right away or don't make it perfectly clear? Test score. I'm going to take that as a yes. Yes and yes. Okay, let's do it. Okay, you ready? Let's do, this is getting down. Okay, I have DataCamp question. I can't figure out why it's not letting me assign a value to roulette with the, Can you copy paste the question into here? Copy paste the question into here. Or Roderick, you're on Discord, right? Send me a screenshot on Discord. So send me a screenshot on Discord and I might just pop it over to this screen. Class is not over. Let me make sure I got Discord on the right screen. Okay, I do have it on the screen. Okay. Class is not over, but is there any way I can upload the visualization through Google Drive? I don't think you can have Word and put it in a Word doc. So I think that's the best way. And Word's free through UTK. I think that'll work. Okay, let's do it. Here we go. Stat 201. You have no iCloud storage. Here, we'll try to figure it out, Keegan. We'll try to figure it out. Wait. Oh, Miranda, you are awesome. Miranda, Vols help Vols here. You answered a question I didn't know. Let me try to memorize that. Miranda's giving tips right here. We're throwing another 10 points to the viewers today because Miranda's helping out right here. And then he's got a question. I'm still confused on my question earlier from where, but I feel like it's too hard to ask. Which question? Can you go into more detail, Hie? Go into detail on it, and I'll answer it. So, which one were you wondering about? Was it shape, center, spread? When to use the proper measure? What is the proper measure of center and spread to use? Yeah, if Keegan, if you can confirm it works, that'll help me when instructing people what to do, because I don't use Google Docs as much. So if you can confirm you can save as a docx through Google Docs, then anyone who uses Google Docs, I'll just say save as a docx through Google Docs, and it should work. And that'll be really, really good advice that I can help out with students, because that's what I want to do. I want to help out as many as we can. There should be multiple options when you try to save the file. Awesome. Thank you so much, Miranda. Vols help Vols. Come to Off Stars and help each other out and throw out some points for all the Vols help Vols. Stat 201. usually has an average on the test of 82 with a standard, nice job, deviation of 8. I know I said different things earlier, but this is a fake question. The distribution is normally distributed. Write out the notation for how it looks. So we're going to do these steps right here. And then what percent of students are expected to score above a 90? Okay. So here's our questions right here. And hey, feel free to put your question in the chat again, and we will do it right next. So I'm so glad. So who can write the notation for how this looks? Who can write the notation for how this looks? Who has any idea? More like goat tier. Vols help vols. I'm very happy when people are answering each other's questions. So the more questions you drop in the chat, the more. Nice job right there, Mun. You're 100% right, Mun. The first number is the mean. The second number is the standard deviation. You dropped it in Discord. You got it, Marant. You got it, Roderick. I'll bring it up next here on the screen. We might do Hie's first because I think he had a question earlier. And there we go. So remember, the first number is going to be the mean of the distribution. So this is the average or the mean. Same thing. Average is the mean. And the second number is going to be the standard deviation. So the standard deviation we got right there. There we go. There we go. Yeah, you got it. You're next, Hie. We got it. And so now, what percent of students are expected to score above a 90? This is the tough one. If you get this right now, you are way ahead of the game. So with this, with this right here, what is it going to be? So hopefully I've answered all the questions. I get so many spam phone calls. Who knows what percent of students are expected to score above a 90? If you knew this, if you can answer this before I show you how to do it, you have super followed along today and you're way ahead. Close. That's a really good guess, Mon, and I know that's a really good guess. Here, Mon, I'm going to not show the answer yet, but you're super close to it. I know where you got 34 from, so you're on the right track. You're using the right number, but the answer you want. If you know how to do this, you're way ahead of the game. Like these questions when you get to the test, which a lot of people struggle with, you'll just be like, got it. So I'm going to let you figure this out real quick. What would the answer be? So if 68% is inside, what is total outside? If 68% is inside, what is total outside? I know it's if you don't use it for a while, you're like, wait, how do I do this again? If 66% is inside, what would be total outside? There's no way I'm selecting all of it. Roger got the right answer now. Roger's like, gotta remember how to do it. To find the total. So remember how we said 68, 95, 99.7, Miranda? Does that make sense? So 32, you got it, Hannah. 32 here. So 32 is the total. And if 32 is the total, then how could we figure out just one of those areas? If 32 is how much total there is, how would we figure out one of those areas? This is like the inside-outside trick. Exactly, Roderick, you got it down. Roderick remembers how to do this now. It's like you just need it quick. I like how Roderick had done it, and then like, oh yeah. You go 68 inside, 32, take half of that. And so the answer is going to be 16%. That's how we do it. And you've just done a chapter 5 question. The 32, how did we get 32? Because what is the total area? And then we're doing Hie's question next. Hang in there, here, we got this. What is the total area right here under the whole curve? Like the whole curve as a whole has how much area? The whole curve as a whole, everything on the curve has, well, I already put the answer. So the curve as a whole. Does this make sense right here? So the curve as a whole, yep, 68's in the middle, 32's outside, and then I shouldn't have the top things color coded anymore because the color coding doesn't go along with what we have. So who thinks they understand this example right here? 68% are expected to fall between exact mirror and an iso equation right there. Then the other side is the rest of the 16 exactly. What, here, we're going to do Hie's question. Let's do Hie's. So Hie, the big thing we need to know to start out is how does the distribution look? So how does your distribution look, Hie? Does your distribution look mostly unimodal symmetric, or does your distribution look like right skewed? Does it have outliers? Does it have gaps? So how does your distribution look? Mostly unimodal symmetric, and then you would be on this row right here, or does it look mostly skewed with outliers? Like, what best describes your data? Does it look unimodal symmetric without outliers and gaps, or does it look more skewed and skewed with outliers and gaps? Which of these best describes it? Option 1 or option 2? I'm going to grab Roderick's question here in a second. So this is how we know. Right skew. Aha, nice job here right there. So this means you're going to use these measures right here. So when you describe them, you're going to talk about the median of the distribution being the center. So if it's skewed, you have to describe with median IQR. Bingo. That's a nice job, Mun. Thank you, Hie, for asking that, because now Mun's especially seeing when it's skewed, as it looks for this bottom part right here, you'll use the median for the center, and then the spread is the IQR. And these are, as you see right here, color-coded for us to see that the IQR is a measure of spread and the median is a measure of center, where when it's more normally distributed, we'll use the mean for the measure of center, and we'll use the standard deviation for the measure of spread. Is this making more sense, Hie? So you look at the shape first. So the shape is how you decide what is the proper measure of center and spread. So you need to describe the shape. Start. I understand what everything is, but I don't know what you're looking for. Oh yeah, Miranda. And does this make sense, Miranda? Does this make sense for only the appropriate measures of center and spread? Does this help answer the question for you? When you look at the shape will determine for you what are the appropriate measures of center and spread. If it looks more like number 1, you'll use mean and standard deviation for the appropriate measures of center and spread, where if it looks more like number 2, you'll use the median and IQR for appropriate measures of center and spread. So describe the shape first, and then be like, because of this shape, we will now use this. Awesome, Miranda. Yep. And yeah, if it looks normal, then you want this right here. And if it looks, because that's what we've been drawing for this every time. And if it looks more more skewed and everything. No, there's no real formulas. When it's unimodal symmetric mean generation. So you won't be solving formulas. You'll go to the output. Let me bring up an output for it. Where's an output? Oh, here we go. So you'll go to output, and here we'll discuss. And then, Project, we got yours next here. So when I go to this right here, how would I describe the center of this distribution? Let me add in an axis on here. Make sure to add in the axis on yours. I haven't always been doing that for all the ones I'm making quickly. So when I describe the center of this distribution, how would I be describing the center of this distribution? Of course, I'm going to do that. Let me do this. And, all right, 2 seconds. I want it to be on a nice, clean background. There we go. How would I describe the center of this distribution? How would I describe the center of this distribution? The center of this distribution, because it is a right-skewed unimodal distribution with tons of extreme outliers. One that's like 77 point, what is that? My gosh. I think that's 742 billion or 742 million. Because if it's not normally distributed, then you have to do the IQR and the median. Yep. Is this making sense, Hie, right here? With this distribution we see, this distribution is extremely right-skewed, has outliers, and has gaps. Due to the extreme right skew, outliers, and gaps, it is also unimodal. What will be the proper measure of center? What will be the proper measure of center? Because this is an extremely right-skewed unimodal distribution with outliers and gaps. What will be the proper measure of center? Because it's an extremely right-skewed distribution. What is the proper measure of center? The proper measure of center will be what? What will be the proper measure, the correct measure of center to use? Exactly. Center is where like the middle of the data is. And so where's kind of the middle of this distribution? The median, Miranda, you're right. Because of the shape. Remember, the shape determines what the proper measure is. So, and it's the 50th percentile, and the median is going to be this number right here, which means the median number of tickets sold or raw sales of tickets is 176,545. That is the median amount of raw tickets sold. So, yep. So it's not a percent. This is like, here, think about this. If we were to have people do push-ups, and I don't know, it's just an easy concept to understand. Like, here, let's do push-ups. And I'm going to put them in order by how many push-ups people could do. So everyone in office hours is going to do push-ups. And then just all of a sudden, just amazing craziness. Okay, so we got a bit of a right-skewed distribution. Here, we'll put these more like, cool. This is how many push-ups people could do during office hours. This is totally random. Did someone say random? Where's my random button? That's the theme of our class. Okay. Okay. Random data right here, push-ups. So this is a right skewed distribution. Does everyone see the right skew nature to it? I'm not so good at grammar either. So what was the median of this distribution? What is the median of this distribution? What is the median? The middle number right here, there is no middle number, but notice how 16 and 18 average together into 17. Is this, yep, does that make sense? Like the 50th percentile of push-ups people could do was 17 push-ups. The 50th percentile of push-ups people could do was 17 push-ups. Does that make sense? That is the 50th percentile. Now, how would we find the IQR? The IQR is going to be the distance this number is away from this number. So who can mathematically figure out the IQR? So just think 53.75 minus this. We can always cheat by going to customize summary statistics. We won't get to click this on the test, so we should know how to get that. But does it make sense how to find the IQR? 53.75 minus 12, and that will get us the IQR right here. So it's the distance these two numbers apart. Yeah, and I would say the 50th percentile, like if this was the one for the visualization, I would say the 50th percentile of push-ups people could do was 17. The range of the middle 50% of push-ups people could do was 41.75. Does that make sense, Mon? So the IQR is the range of the middle 50%, and then give the context of the data. The range of the middle 50% for push-ups people could do was 41.75. The 50th percentile of push-ups people could do was 17. So we won't have to find standard deviation, and standard deviation would not be the proper measure of spread for this because of the right skew. Standard deviation is going to inflate it. I know, God, I'm sorry, just say Brian. So the standard deviation and the mean are inflated because of the skew. So the standard deviation and mean are improper measures of center and spread for this one. Does that make sense, Miranda? Because of the skew, we cannot use the mean and standard deviation because they're going to be inflated. They're going to be not accurately representing the data. So hopefully, does that make sense too, Hie? That we have the proper measures right here. I meant just in general, like a simplified answer to how to. Oh yeah. So no, good question, Miranda. The good news is we'll never find standard deviation by hand in this class. Oh no worries. So to find standard deviation, just right here, the craziest question we could ask you. I can't imagine this appearing on the test. If you square standard deviation, you get variance. Variance is in squared units. I'm just like a random note to take. So variance is standard deviation squared. So if you notice, I just squared 45 and I got variance, which I didn't carry all the decimals. Exactly where it says standard deviation, yeah, right there. And then, why is my brain? Oh, the standard error, the mean. We'll talk more about that later. But that's just 44. What's square root of 10? This is a concept for later. This one you might, it's divided by the square root of 10. That's why you get that right there. So the standard error of the mean is the standard deviation over the square root of the sample size. We're not covering that right now. So for as of right now, all you need to know is the standard deviations in the output. And what do you notice is right next to each other? Very important thing to notice. What concepts are right next to each other in this output? In this output, the mean and the standard deviation are right next to each other. They go together. Remember that? Mean and standard deviation are for normal data. And then also you have the median, and the median is right next to what? The median, this is big. We're going to go to Roger's question next. The mean is right next to the what? So the mean is right next to the standard deviation, and the median is right next to the wet. It doesn't show it on there, but it's right next to the IQR because the IQR is just that distance right there. So huge things right here. If you see that the median and the IQR are in this output and the mean and standard deviation are in this output, you can kind of remember which ones go together because they don't mix together. Does this make sense to everybody? Which ones we use and when? This is going to be for like skewed data, and this is going to be for normal data over here. So hopefully this screenshot can help you too to understand when to use the median and IQR and when to use the mean and the standard deviation, just like looking at your jump output right here. So kind of a big important thing. If you take notes by taking screenshots, I would screenshot that and be like, okay, this output on this side right here is for skewed data, and this output or skewed outlier data, and this data is more for normal data. Let's go grab Roderick's question. Hey, did that help out a bit? Does it make sense what standards, what measures to use? I think, okay, wait. Roger, did you send, I think you just sent it to me, right? I think I know which person you are. Let me double check. 248. Does your name, you here? Okay. I'm too afraid to, let me double check. I'm too afraid to like, wait, is this the one? Let me double check. It is the one. Okay, I know which one you are now. Because if I click messages in Discord and I go away from them, I'm too afraid I'll lose them. And I don't want to like lose the messages. So I'm going to screenshot your image. I'm screenshotting a screenshot. I don't want to like lose and like click on someone's message and then go away and then forget to reply, because that's the easiest way I forget to reply. So there you go. Yep, that's what I thought. And I didn't want me to say that. So as long as you're good with that, yeah. I was like, I think that's you. So, so here we are. So this says we're putting in the days vector into the poker vector. Oh, that's the name. So another way to find the midweek result is poker vector results 2 through 4. So the square brackets are going to give us the positions in the vector. So looks like there's an issue here. Oh, wait, I see it, I think. So, yes. Okay, wait, I see it. This portion of the code right here is going to, we need to make a square bracket. So we won't concatenate this right here, which you could actually, you know what, just take, I wish I could, let me grab white. Where's white? I think you can fix this really quickly. Hopefully you still have it up. Let me change this to a white pen. Oh, that's way too. Will that work right there? Tell me if that works, because they want you to, that should work. If you put that inside of brackets, yeah, give that a try. I don't know if you can highlight code on theirs and do it. So right now that is, it's the code, it's 2 vectors, because I can explain why this should work a certain way in a moment. Right now the code really doesn't make much sense. Don't worry. Peach would look at my code and be like, Brian, none of your code makes sense. Because right now you have a vector next to a vector and there's no operator. Good stuff. See, this is good for my knowledge too. I'll explain what you had, and then, so you have right here, like, let's just call this storage. This is what you're storing into. And then you have here, you're trying to take like a vector, which this vector, yours is names, I believe. But here's the vector, and this will work. But then what you had next to it was another vector of like elements 2 and 3. And you see, now it's getting mad right here, because what we want is we want to take positions. I see, even I did it wrong there. This will give us the positions. So this big thing right here to see is that square brackets gives us positions. So now you're saying go inside of vector and take positions 2 and 3. So you'll see in storage right now is 2 and 3. And we can make this a little easier to understand what's going on right here by going like 9, 9, 3, 2, 4, or in the 9, 9. If you notice, let's say the 9, 9s are like data we don't want. Now we're only going to get positions 2 and 3 inside of storage. So it's saying go there and take positions 2 and 3. You can actually just do it with just this right here, because that'll make a vector and run that. You could choose certain things though. This is when we'd use C. So Roderick, what do you think this will produce right now? What will be in storage right now? With what I've written right here, what will be in storage? What will go into storage? And this is a good review right here of DataCamp. what will be saved into storage by doing the following? Because the square brackets goes to positions inside of that. So what will be in storage with the following? You are correct. You got it. Is that making more sense right there? Hopefully that makes sense what the square brackets does. It says you're inside of this vector taking positions. So when you do this right here, and we'll be covering that, I think you're in yesterday's class, but we like, don't worry, I want to answer all these questions. I want it to make more sense. Like, that's my goal as we go through and do this. I'm also afraid my neighbors are one day going to like hit the ceiling, like, shut up. I learned how to like talk quietly in Knoxville, and my neighbors did like. So square is pulling from the vector, yeah. So square brackets pull positions, but here's something I want to show you real quick too on this. So with this iris data set, so the iris data set right here is a data set of flowers. I can't do anything right today. So here's the iris data set. How many dimensions does the iris data set have? What is the dimensionality of it? Like, is it a one-dimensional vector? I know, right? Is it a one-dimensional or two-dimensional or three-dimensional? Because things can have more dimensions than one or two. How many dimensions does this kind of spreadsheet have? 2D, exactly. So let's go down here and go to iris, and you can use, there's a way of doing it without the comma. So the first thing I'm going to put in, what do you think the first thing I'm going to put in? It's going to tell it what to take from. The first thing I'm going to put in is going to tell it where to go to. Just think two-dimensional stuff and look at that. So if you look at that over there, it's going to tell it what to go to with the first thing I put in here. Think of matrices. So it's going to tell it the row, then column, exactly. So let's go here and let's go here. What will this return? When I run this code, what value will it say? When I run this code, it says go to row 3, column 1. When I run this, what will it return? What will that return right here? Kind of looking at the, exactly. Yep. Oops, I didn't hit the right button. It'll return that. But what if I were to do this? What if I were to do this? Oh no, I don't want to do that. Don't look at that. I was like, wait. What if I were to do this? Let's do that. So now this says take rows 1 through 5 of column 1. Does that make sense? It says take rows 1 through 5 because that's in the row space, and take all of column 1. So or take from column 1 rows 1 through 5. So I'm going to get 5 values here, and it's going to be the 5 row values starting with 5.1, 4.9, 4.7, 4.6, 5.0. And does that make sense what that code right there just did? Hopefully that does right there. It says take rows 1 through 5 and take all of column 1. So the first thing I enter for the first column will be what rows am I taking, and then the next argument is what columns am I taking. And I'll show you something pretty interesting. Is that making sense, Roderick? It gave me rows 1 through 5, column 1. So it says, and always like the rows right here, rows 1 through 5 of column 1. What if I were to do this though? This would give me rows 1 through 5 of what? So this says take rows 1 through 5 of what? So just take a moment and think about what changed here. This says give me rows 1 through 5 of what? So this is really good practice right here. Like if you understand what these, like if you understand what it says, give me rows 1 through 5 of columns 1 and 2. Yep, there we go. Give me rows 1 through 5 of columns 1 and 2. What if I were to do the following though? What if I leave it blank? So I want you to see what happens when I run this, and then I want you to tell me what happens if I leave something blank. It gives you what? What columns does it give you if you leave one of those arguments blank? If you leave one of those arguments blank, what columns does it give you? So the columns argument is now blank. So I said, give me rows 1 through 3 in columns what? So what columns did it give me since it was blank right there? So leaving one of those blanks will just return what for those values? If you leave it blank, all the columns. So what if I also leave the rows blank? If I just put this right here and don't put anything to return in them, if both of them are blank, what will this return now? Remember, it gave me all the rows when I left it blank. Don't worry, it's not a trick question. Just expand upon if it gave me all the rows when I left it blank. What happens if I leave all the columns blank? You're right. That's it. You're right. So you could get all of column 1 with this. there's all of column 1. So I left the rows blank. That's all the rows and column 1. Is this making sense right here? So you just specify what you want. You could say, just give me, rows 10 through 15, and there's rows 10 through 15 of column 1. But you can choose. So hopefully this is making sense how to do it right here. Also with our vector we created, do we call it vector? If you leave it blank, it'll return to you all the vectors. So it works the same in the other dimensionality too, where if you just leave it blank, but you could also like remove a value. Like you can remove out any values you want. You can say like remove this value. Exactly. It's like you can use it to subset. So you could use it to subset data. It's a really good way to like subset or select data. Hopefully it's making like all this practice right here is really good on like how to work with data frames, how to work with vectors, how to remove data. Really good practice. Because actually, you know what? I did it. I think, were you here for office hours earlier when I did the MuBot points? So I was actually able to remove, and we looked at the points so far that people have. So I ran some code right here. Did I change it? We got the histogram right here. Here's the histogram of points for people, and really, really good distribution of points so far. What other questions are there? Everyone's checking out their points. Over 1,000 so far. Sarah's leading the way. You know what we could do? So wait, is this data normally distributed? We could find the percentile of points. So watch this. What do you think the top 10 percentile? This is what's so cool about. So let's go here to data, because I have it stored as data. The top 10% of people. What did I do wrong? Oh, is it not quantitative? Oh, it's got the NA. Let me fix this. 2 seconds. Was it not numeric? Data is .na. Oh, we have to put NA remove on it. Okay, cool. Oh, that's the 10th percentile. I'm a fool. The 90th percentile of points. It's skewed to the right, right to the high. Skewed to the right. The 90th percentile of points is 700 points. If anyone wants to check their points, so Miranda and Hannah, you are well above the 90th percentile of points. Let's look what the top 5% is. The top 5% of people have 840 points. You're well above that. My gosh. The top 2% of people, what? You guys are in the ridiculous percent. The 99.99th percentile. So, Sarah, you're in the 99.99th percentile of points. So, because Sarah's second. Show up and go up. Exactly. That's what we do. So, office hours get those points high. Exactly. Yeah, no, just keep attending office hours. Come in when you have questions. I don't mind that people just get tons of points by coming to office hours. I mean, could you imagine someone at the end of the semester? Love it. Could you imagine someone at the end of the semester being like, how do I get points? You'd be like, go to office hours, ask questions, just swing by. If you're stuck, let Brian know. And I hope everyone knows, like, I try to do as many questions as we can. So, and that's why I like recording office hours too, so we can like go through. But one thing that's really nice, you're wondering, Brian, that took a lot of work, but watch this, data. It'll give you a summary of the data right here, giving you the quartiles. And you can see like 50% of the class right now has between 400 to 550 or so. So 50% play Among Us. Were you in on that, Sarah? Did you play? Are you a nerd person? Is that Sarah? I don't know. So, oh, thank you so much, Miranda. I really like that. So we're just here to help out. That's what we do. Help out with the topics and hopefully bring some more understanding. Yeah, if you get Discord to work, we'll probably play it tomorrow. I've got that meeting and everything, but we'll probably play it tomorrow and have some fun. And, a lot of people have some good points right now. It's, 25. What does this first quartile mean? This is going back to, and these are the proper measures, but what does this first quartile mean right here? Can anyone give context to the first quartile? What does the first quartile mean right here for the data? Explain to Brian what the first quartile means of the data. Like 25% of the class has blank or blank. What does the first quarter mean of the data? Which is somewhere around here. Cool, my girls thought it was so funny. I was playing last week. They wanted to help out tomorrow. Oh, that's so awesome. Yeah, have them help out. You can have them play if they want. You can have them log in. What's up, Elizabeth? So good to see you, Elizabeth. 32474, right? So good to see you here, Elizabeth. MuBot's here. I love it. Former students combined say, hey, I think Elizabeth, former student, right? 474, did you take, Elizabeth? I think so, right? Correct me if I'm wrong. What does the first quartile mean? We're analyzing points this semester. Set to 1 in the mini. Oh my gosh, so long ago. My gosh, that's almost a year ago now, Elizabeth. And that's when I had I was streaming from Knoxville. Oh wait, Elizabeth, were you there the morning my neighbors banged on the wall for me to shut up? I was teaching and being like, "Wah, wah, wah," and then I heard them knock and I was like, so that's what happens when you start teaching a class at 9, 8 a.m. in the morning in Knoxville in an apartment. So we were there. I haven't gotten a haircut since then. No, I did get one haircut. My fiance cut my hair for me. So I've gotten one haircut. One haircut. You're welcome. Good job, Miranda. We're just relaxing here. We're about to finish up. Because I think we've done most of the questions. The first quartile here would mean that 25% of students have 25% of students have earned 240 points or less. The third quartile here would mean 25% of students have earned 555 points or more. So that's what the quartiles mean. The 50th percentile of points earned by students is 410.7 points. We have a lot of new stuff, Elizabeth. We've got the boss battle. We've got music now. Let's hop over to the main screen. I didn't even have this before. I made this one, I think, when I got to Texas. This was an August idea of last year. Time is just flying by. Done a lot of big improvements. Let's put on some nice music. Yeah, thank you, Elizabeth. And Elizabeth came from the team. Elizabeth, what name did we come up with ourselves? What name did we come up with ourselves, for ourselves? What was the name we called our channel, our group? Stat Nation. Elizabeth is from the original Stat Nation. She is Stat Nation. You know what? Elizabeth, I think you might have been here long enough. Mewbot's going to give you some points right here. We added Mewbot in. We did have the bot before, but Mewbot now tracks our points. You can also track my errors. I can give out points a lot easier now. I have a command in the chat, Elizabeth. I don't yell out points anymore like I used to. Times change. See, oh, you have points. Yes. So watch this. Another 10 points, Elizabeth. And let me go ahead. Logan was here for a little bit. We're going to add some points to Logan. Elizabeth, being an original Stat Nation member, don't show too many people this. Elizabeth gets to join in on this. I'd be honored if one of our original members, Elizabeth, check us out right here. If you want to check your points, Elizabeth, you are now, I think you have more points than me. You get to see the secrets right here. Don't tell everyone the point secrets. Does it show? So your status will change. I just changed your points. But now it tells people how much extra credit they have. So I'm honored that one of our first Stat Nation members here is going to get, I know, and when Mewbot updates, it'll change what your status is. I can't change that. Mewbot has to change that. So you notice Sarah's says legendary tier. You're going to have the highest tier. So Sarah, don't tell anyone. That's maybe what the highest tier was. There's one tier above it. But we're just having some fun here, finishing off. Any other last? No, I'm honored. Just to think, I try to tell my students this as we just had 7 more minutes off, so we're just chilling out, listening to some music. But the what I do with this class builds. I didn't come up with Stat Nation. You guys came up with it. You guys remember that? It was everyone's like Stat Nation, and I was like, okay, we're Stat Nation. Let's do this. And I like this idea that this is too sad music. We'll play this again. This is happy sad, happy sad chill. We don't want to go too sad. Any other last questions? I'm glad this class can give people something to enjoy. Still one of the best UT classes. Y'all are like, oh, thank you so much. I'm getting a negative number. Which negative number are you getting, Miranda? I hope soon as this world gets a little more back to normal, we're going to come in. If my fiance could fly in with the weekend for me, I'd fly her back. I'd fly her to Knoxville just so we could go to Knoxville, go to Taste of Thai. Just she and I would fly in when the world's a little more back to normal. So the IQR, just turn it positive. And here's a way to cheat. Let's hop over here and let's cheat and get that answer. Let's do this. Some music in the background. So do this with your data open. Once you make your graphic, not going to cheat with that. So once you make your distribution, then go here to this button. So click this button right here, and then go to Customize Summary Statistics. Under Customize Summary Statistics, go to Interquartile Range. So click Interquartile Range, and then with that, you will get the IQR. Now mine's totally different. I did a different thing. But when you get this number, double check that you know how to find it. Bring up your calculator, find Q3, type it in, 342, 9, I'm going to make a mistake, aren't I? Minus 2554. There was the mistake, obligatory mistake. There we go. So does this make sense right here? Double check it once you get it to make sure you understand how to get it mathematically for the test. So use the tricks you can use with the software to get it, but then check your knowledge to make sure you know how to find it. How's that sound, Miranda? I'm gonna play Down next. Yeah. Let's show that again real quick. You ready? We'll do another one. We're going to go to Analyze, Distribution. Why not Gross Sales? I don't know if that's the one or not. So here we are as the distribution. We're going to go to the top arrow. We're going to go to Stack. Maybe you can always rewind this. I was trying to find my file. Okay. And then we're going to go here. I always make this a little bit bigger. Meant to pull here. I just like it to fill a little more of the screen. You don't have to do that. Click here to Histogram Options. Go to Count Access. This is going to give the count access to kind of show how many observations are in each bin. Bin width is 25, it looks like, right? 25, 50, I think it's 25. Not that important, but short bin width. You can cheat, find out the bin width. That's not telling me yet. So here we go. Customize Summary Statistics. This is the key thing. Do you see this arrow I clicked? That's the key thing you need to know to click to be able to find the IQR very easily. Make sure you know how to find it mathematically. But click the Summarize Summary Statistics. Customize Summary Statistics. Is this button available for you, Miranda? I'm going to pause right here and make sure you're on track with us. Is this button not available? You said no recently, and I don't know if that's to the button being available. How do you get here? Go to, do you have the data open, yes or no? You can type wire N for the questions. Do you have the data open, yes or no? Open up the data first. Sad chill music. Do you have the histogram open, but it's not, okay, good. Are you currently on a screen like this? Does your screen look like this? Okay, good. Now that you're on this screen, do you see a red arrow here right next to Summary Statistics? Do you see that red arrow? Is there a red arrow next to Summary Statistics? Good. Click the red arrow. And then go to Customize Summary Statistics. I went through like all the piano music I can use. Good. Go to IQR. Now, I'm going to look here and I'm going to see the IQR goes from 208 to 213. It's the 75th and the 25th, their distance. So I'm going to select IQR right here. And once I do this, mirror 2008 to 2013, boom, it's 5. It's just the distance between those numbers. So checking your knowledge is kind of key too. We're not just going to use the software to get the answer every time, because maybe on the test we'll have to find it and know how to get it and understand what it is. It's the range of the middle 50% of the data. So the middle 50% of the data goes somewhere from about here to about there. This, I guess more like, oh, there it is. Why don't I just go to the box plot? Because that's where it is. So the range of the middle 50% is that box of the box plot. That is the IQR from there to there. Really? There you go. That is the middle 50% of the data. So, and it should be positive. The IQR is always a positive distance. So the IQR is always going to be, if you subtract it reverse, it'll be negative, but the IQR is a distance, so it's positive. It's like this is how far these numbers are away. And you should get a positive number here. You just might have done Q1 minus Q3. But whatever this number is here, which you can put in your output, that is the answer. Is that got it, Miranda? I think you got it. Great job. Great work. Getting the assignment done. Yeah, that's it. I should have just guessed that. I should just... And so the IQR is always positive. So it doesn't matter really which way you subtract it. Just remember it's positive. No, thank you. That's got it. No, I appreciate all the hard work. That's what we're here for. Office hours technically end right now, but when people have questions, I don't want to leave. Because I want everyone to get the answers they need. I might change the outro song because I feel it hits a little hard. It's like, wow. When I'm playing all this like chill music. But that's it for now, everybody. I will see you later, especially if you're in BS 320. So bye for now, everybody. Bye.